DNS. In this nugget, we'll be discussing DNS, or the domain name system, or sometimes the domain name service or server, it doesn't matter, but typically we just call it DNS. In any case, we'll take a look at an overview of DNS, what its job is, how it does what it does, and how it uses referrals. We'll also take a look at separating namespace. This is a critical issue for corporations, universities, any place with both a public internet presence, like a web page and mail servers out on a DMZ, as well as the private network where you want to protect your internal clients and your mail servers and your SQL servers and things like that. So we'll talk about separating the namespace there and to avoid overlapping namespace. We'll also talk about querying DNS. Here we'll actually do some queries against DNS servers to see what kind of useful information we can get out of them. You can use this for part of your footprinting process, and you can get some identification for servers that are very likely targets for you. We also will take a look at SMTP, which is Simple Mail Transport Protocol Open Relay, and this will be launched out of information we get out of querying a DNS server. We'll find a mail server that we can potentially exploit. Did you ever get frustrated because you couldn't find something? I mean, that happens all the time. Sometimes my wife and I will be ready to go somewhere, and she's kind of notorious for losing her car keys. So if we're taking her car, we usually have to spend about 10 or 15 minutes around the house just finding these car keys for some unknown reason. She can't just keep them in her purse or in her pocket. I also have a tendency to lose things. Last night, in fact, I couldn't find the remote control. I'm yelling at the kids, "Kids, where'd you put the remote control to the TV? Man can't live without his remote control." I'm waving my arms and, all this. Finally, I looked down at the coffee table, and there it is right in front of me. Well, finding things is of critical importance not only in life, but also in internet and networking solutions. And that's why we have DNS servers, and that's what we're going to also be able to exploit to send people down the wrong path at times. Well, before we can understand how to exploit DNS, however, we need to first of all understand how it should work properly. This is something that even a lot of network administrators just don't really have a grasp on. I think the reason for that is because a lot of times in many organizations, it's only a few administrators that are responsible for managing DNS. So a lot of people don't really get the same experience with DNS as others. Let's go ahead and take a look, however, at how DNS should work, and then we can understand better how we can work with it to exploit it or to misdirect it. First of all, you have a DNS client right here. This would be whichever computer. This could be you. This could be you looking for a specific website out on the internet. So maybe you needed to find www.west.cbtnuggets.com. Well, what happens with DNS is, first thing the client does, and this is generally true across all operating systems, it looks to see if it's got that name resolved already in its client cache. So at some point in the past, in the recent past, if I've already found that server, well, then it'll just remember the IP address of that server, and then I'll just look in my cache. I don't have to go to a DNS servers that way, and I don't have to do iterative or recursive queries. I'll do a recursive query, technically. We do a recursive query to our own DNS server, and that's the way clients work in client operating systems. And this is not critical to Certified Ethical Hacker, but just since I brought it up, recursive means either get me the answer or don't do anything at all. That really means that if I don't get an answer from you, then I'm not going to have any other recourse. I just want an answer from you, and that's pretty much it. So that's what would be called a recursive query. Now, what if the client cache does not have the answer? Well, at that point, it can also look at what we call the hosts file. The host file is actually going to be read into the client cache anyway, so the contents would be there. But the host file would be a manually configured file, and it's not host.txt or anything like that. It's just located on that DNS client, and the exact location will vary from client operating system to another. But it'll just have a translation of what's located there. And we don't see that too much, especially in Windows hosts, because it's not necessary like it used to be back in the early days of the internet, where we'd have to manually enter in all our query resolutions. So in any case, if it can't find it in any of these locations, then it goes to its configured DNS server. And maybe this is the DNS server right here. And this DNS server really only has one zone, nuggetlab.com. But nuggetlab.com will also look inside of its cache, and if it's in its cache DNS. This is going to again be a cache of names that it's been able to successfully resolve in the past. Well, in most cases, in this case at least, nuggetlab.com doesn't know anything about www.west.cbtnuggets.com. It's not authoritative for that zone. But in this case, it'll do iterative queries where it'll say, well, I don't know the answer, but I'm going to keep asking all my friends until somebody gives me an answer, and then I'll try to get the answer and send it back to you. So what happens then is NuggetLab.com says, since I have no knowledge of cbtnuggets.com, but I do know that I can go to the root servers, and we're assuming internet servers here. So we'll go to a root server, which is initially just the dot servers. And the dot server says, well, I don't know CBT Nuggets either, but I do know where the .com servers are, and here's one of the IP addresses that you can use. So NuggetLab.com will say, okay, .com, do you know further up the hierarchy where I can find cbtnuggets.com? Well, of course, .com will, because that's its job. Its job is to track .com servers. So then it'll say, yeah, I know the answer to that. Why don't you go to cbtnuggets.com? And we got the DNS server here, which will then say, hey, you're looking for west.cbtnuggets.com. Well, I don't really host the zone for that, but that's a close friend of mine, so I'll give you the answer to where you can find west.cbtnuggets.com. And none of these other servers would have had that direct answer, so we're getting a little closer. It's like that kids game where someone, hides something in a room, and you try to walk around, and they say, warmer, warmer, no, cold, 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 warmer, warmer, red hot, red hot. Well, here we're getting pretty close, at least, to red hot. So we finally make a query again, another iterative query, down to west.cbtnuggets.com. We get an answer back saying, hey, I've got probably for www servers, it's going to be an alias record as well as a host record. So it'll eventually return to me the exact answer, the exact IP address that I need on this DNS server to be able to access this server right down here. So once this NuggetLab.com DNS server finds the answer, then after all that work, it sends the answer back to the DNS client, which will then cache that answer in its client cache according to the time to live. So that's kind of the bullet tour, or the short version of how DNS is supposed to be able to work. So then how does a hacker take advantage of the ability to poison DNS? Well, I've drawn in a couple of things here. What we have here is somewhere lurking out on the internet is a DNS server from a hacker. And it's also got a zone called west.cbtnuggets.com, quote unquote, because it's not the real DNS server, but it's impersonating that cbtnuggets.com server. All right, then we also have their own web server over here, not the real west.cbtnuggets.com, but their own impersonating web server. And it's very likely that they've used wget or some other utility to download all of the web pages that they can grab from this web server over to this one to make it look identical to the real one. And then within that, they could have put some kind of spyware, trojans, viruses, any other item that would allow web pages here, when it goes back to these clients up here on this network, to load that Trojan and allow us to eventually take over these computers and run them as if they were our own. It's kind of a race against time sometimes. This is also known as just a race condition, because we might be able to put out our server out there as well, and we just want to try to get our server with the same exact IP address as this server on the network, and hopefully it'll go undetected, at least for a brief period of time. This, by the way, is not something we'll park out on the internet for days at a time. We just park it out there long enough so we can get some results, and then we'll probably take it off so we don't be too obvious. But there are certainly ways of detecting more than one server with the same IP address out on the internet. In any case, it could be that this DNS server is getting slammed. It could be that I've already launched a denial of service attack against it, so it's responding very slowly. That way, when this NuggetLab.com server responds, it's going to go to this one because I'm not very busy. I'm just waiting for hacking traffic to go on. So it could hit me first, and then I could redirect those clients. Again, this is one of those things that's not 100%, doesn't work all the time. You just have to hit and miss, and hopefully you'll get lucky enough to be able to poison a cache somewhere. And this could be a pretty complicated process. For Certified Ethical Hacker, we are mostly concerned with the fact that this can happen and the overall functionality of it. Probably the best paper I've ever seen on this, however, and I'm just going to go ahead and take you to a website that's excellent with this, is www.lurk.com/cache poisoning. HTML. And just make note of this website here. This is an extremely in-depth article on cache poisoning, and it shows the probability of collision here. This is kind of what I was talking about before with race condition. There's something called a birthday attack where what you're trying to do is to mathematically get yourself ahead of the other DNS server and increase your probability of being able to send your own answers back instead of using the real DNS servers. Now, does this work all the time and do you have 100% success? No, it has a pretty low success rate actually because of a number of things. Number one, DNS servers are harder to trick these days than they used to be. They have certain things such as a nonce, which is something that's used to validate the sequence of events that take place in a DNS query to make sure that it came from the right one. There's also such a thing as various options within DNS products that will prevent cache poisoning. So this does not always work, but there are still certainly DNS servers out there that you can exploit this attack against. The best chance for making this work, however, is if I do something else to this server, such as a DOS attack, denial of service attack, so that it's unresponsive or responding very slowly. Then in a race condition, my server, which is not very busy at all, might be able to respond faster than this server, and that way I can poison some of these server caches with the incorrect information, pointing it to my virus Trojan horse laden web server out here that will redirect the clients. Now, another thing that's taking place instead of this, especially for financial gain among hackers, is, and you've probably gotten spam for this, is those spam or phishing attacks in which they'll say, hey, this is a message from PayPal. We think that your account has been compromised. Click here to clear all this up. And it looks like a PayPal link and all of that. But in reality, it redirects you to one of their own web servers, which in turn is not really going to even have the same name probably. It's probably just going to, if you look carefully at the URL there, it's probably some IP address instead of the actual name of the server from the real company. Now, all the details for cache poisoning are quite involved, and there's a lot of mathematical probabilities in terms of whether or not I can get my DNS server ahead of yours and beat you to the race condition there. The best article I've ever seen on this is from this web address right here, and you can make a note of this that you see up here. Excellent, excellent article on DNS cache poisoning. And this will probably get you more than you'd ever want to know about cache poisoning. But other purposes for using DNS is that we can use it to, again, further footprint our network so that we can identify what kind of servers to hack into or to exploit. For example, maybe I want to find, I don't know, a mail server and want to exploit that. Well, potentially I can get MX records out of DNS. And that will help me to exploit then those mail servers. Now here let's also take a look at the way DNS often works within a corporation, especially if you've got something like a DMZ here. A DMZ is usually bound by two firewalls, and within this DMZ we have things such as our mail servers. What else would we have in there? An FTP server maybe, FTP, web servers, those kinds of things that we really do want to be publicly available to the internet at large, because we have brochures that people can download off of our FTP server. And we want them to see our company website, and we want them to be able to send us email. So all those kinds of servers could be in our DMZ, or demilitarized zone, between those two firewalls. Now, ideally, what should happen here is, and this whole domain is called cbtnuggets.net in this case, okay, and I've just abbreviated it this way. Ideally, this server right here should only show the host records or alias records or any of those kinds of things for servers that are safe to allow out onto the internet. So that would be these servers, in fact. However, I do not want it to ever reveal the IP addresses of my internal workstations, or where my SQL server is internally here, my file servers, my SMS servers, any of those kinds of things. I don't want to be stored on this DNS server because I don't want the public internet to know where those servers are located or anything about the services that I'm running on my private network. So this is typically our private network, and this is our public network or our network in our DMZ. Now, what I've seen a lot of companies do, and this is usually in a smaller to medium-sized company, and it's just because of inexperienced administrators or naivety, and what's taking place here is they say, well, everybody sends their mail to cbtnuggets.net, and because of that, we think that we have to have our internal organization here be cbtnuggets.net as well. In other words, we want this to be workstation1.cbtnuggets.net, workstation2.cbtnuggets.net, fileserver.cbtnuggets.net, and so forth. Well, that is certainly a possibility, especially if you use bind DNS servers, because there's something called split horizon, and there's a few different ways of configuring it, where you could allow that to happen. But in a Microsoft architecture, this would be called an overlapping namespace, and Microsoft highly discourages this. They do not recommend this at all, because the danger there is that with overlapping namespace, cbtnugget.net externally, cbtnuggets.net internally, that our workstations and our servers can get transferred from these DNS servers to this DNS server. And what would happen then is, let's say all of these workstations, and I'll put a server on here as well. I guess I should make it, realistic. This is my file server. All of these host records are now stored on DNS1 up here, let's say. And DNS1 would be my primary DNS server. a primary DNS server, making too many marks here, primary DNS server is a read and write copy of the zone file. Now, there's only one primary DNS server, but I might have multiple secondaries. This might be a secondary here. Okay, this one may also be a secondary, and this would be a misconfiguration, by the way, but it does happen. This would also be a secondary. So what happens here is that this DNS server would will allow zone transfers to this secondary and this secondary, meaning that all of these host records would be on this public internet-facing DNS server, and someone could query against it and find out what all the names of my servers are and my clients are inside the network. And this would mean also, by the way, that my mail, FTP, and www server, I would have to store those records on this DNS server as well, because they have to get transferred by zone transfer to this server, and they have to get transferred by zone transfer to this server here as well. Well, you can see why this would be inadvisable, because I've just exposed my entire internal network to the internet. So Microsoft's recommendations are, there's a couple of things they can recommend, but one thing you might consider is that you just name these separate domains. Instead of having my internal network here be cbtnuggets.net, instead make it be cbtnuggets.local, okay, or some other domain. And I can still get mail to, James at cbtnuggets.net. There's ways of handling all of that. It'll still deliver mail to my workstation. It doesn't have to be the same domain internally as it is externally. Now, the reason why I would use .local internally is because .local is not a routable domain on the internet. Because remember, if you looked at our previous diagram, I showed root servers and it shows .com. Well, there's also servers that it shows .edu, .gov, and so forth. But there is no zone out there on the internet for .local, so it can never be resolved by name. Now, then another mistake that some administrators make is they make this, instead of making this a secondary, they'll make this also a primary. So it'll also have a read-write copy of its records. This is very susceptible then to a hacker being able to get through the firewall here and being able to write records to cbtnuggets.net here, and then there's no telling what could go on from that point on, because the hacker can pretty much just redirect traffic wherever he wants to at that point. So again, always make the one in the DMZ, always make it a secondary server to some primary somewhere. Another alternative would be, if you want, you could make another DNS server internally here. You could make it the primary read-write for your public records over here, and this would not have any host records for your private network here. Only this one would. So you got two read-write ones, but this one is only dedicated to this particular DNS server here, because this one's the primary, and it transfers the records to the secondary. All of these kinds of records right here are really stored on this server, and then we just transfer them via zone transfer to this secondary. Now, since this is a secondary, that's again a read-only copy of the zone file, and nobody can then make write changes to it. Now, of course, these kinds of precautions don't make any of this impervious to attack. I mean, all you'd have to do is to send someone an email with a virus in it or a Trojan that would then spread throughout the network. We could infect this DNS server. We could Trojan it in that case, or we could do some kind of remote control to it. Then we could poison records here. We could poison records here. We could send out the poisoned DNS records over here. This could go on and on. But at least it makes it so that this whole network now is not low-hanging fruit and an easy target for hackers. All right, let's go ahead and get started with querying some DNS servers here. Now, what we're going to be doing here is just a number of different ways of deriving information from these named servers. And then what we'll be able to do with one of them, at least, is to take some of that information to launch a different kind of an attack towards the end here. So let's go ahead and start off with just one of the basic tools. You can use this in Linux or in Windows. I already happen to be in Windows, so I'll just go ahead and use it. NSLOOKUP. Now, this is fallen in favor of dig on a lot of Linux machines. A lot of people like to use dig instead. We'll use dig a little bit later on from a graphical user interface, however, and you'll see that as well. Overall, it still gives you the same kind of information. It's mostly just a matter of preference. Now, what I want to do next is to set the type of records that I'm going to look for. So I'm going to set type equals NS. That stands for named servers. This is going to give me the authoritative named servers for whatever domain I enter in there. So what I'll do now is go ahead and type in a domain I'm interested in. Let's see, universities are pretty good. How is it about Arizona State University.edu? Let's see what we get out of that. Okay, that tells me then who the named servers are there at ASU. Now, the way this reads, it's a little bit misleading if you're not used to working with NSLOOKUP. It says, where did I get the answer from? Well, the DNS server that answered me was my own local DNS server, DC1 right here. And this is the IP address of that server. but it was a non-authoritative answer. And then because of the colon and the fact that these are listed underneath it, it makes it look as if these are all non-authoritative. Well, that's not true. Really, that's a reference to this DNS server that gave me the answer. These that appear down here, anything that says name server equals, well, name server, these are all authoritative name servers. Now, in all likelihood, one of these is a primary DNS server, and the other ones are probably secondary name servers. A secondary name server is still authoritative because it has a record, a full record of that entire zone. Just because it's secondary doesn't mean it's not as good somehow. All right, now let's go ahead and take a look at another kind of record. Let's do a set type equals MX. It's really, really useful to figure out what the mail servers are on a destination target because those are potentially exploitable targets there. And then I'll again run it against asu.edu. And then I went ahead and typed in some other things here as well. Let's just identify those. I set type equals SOA, which is the start of authority. This outlines the characteristics of that zone on the internet. And we'll see that as we look into the record. Again, it was resolved by this DNS server, which is non-authoritative, for asu.edu. And by the way, let me pause here for just a moment to point something important out. This is my legal disclaimer. I'm not hacking into asu.edu. I would, of course, never ever do that. The reason why I'm pointing this out is just this is all public information. Anybody can get this, and ASU makes this available, and they have to if they want to have a life on the internet, because this has to be made available for DNS servers. So anyway, my primary name server, well, there's a surprise. It's ASU DNS 4. Now, if I was just guessing, going back up to our list of servers, it's up here, there it is, I would have said, oh, one's probably the authoritative name server, you know, the primary name server. Well, in reality, it looks like it's number 4 here, so that gives me an idea there. If I wanted to make write changes to a DNS server, I would have to, of course, look for the primary name server, because any of the other servers would be only secondaries, because there can only be one primary. So all the others would be secondaries, and I wouldn't be able to make write changes to it anyway. Would be a waste of my time. Also, we see default TTL is 1 day, so that if anything has resolved against one of these servers, then we know that it's going to cache that for up to a day. So if I'm looking at a timing issue of when I want to poison the cache, and if I need to kind of thread the needle, so to speak, to be able to get certain things to happen at a specific time, then that might be important information for me to know. Now, the next thing you might also notice here is this says responsible mail address, wilsondns.asu.edu. Well, that doesn't look like a mail address. Is that supposed to be email? It is email. It's just that in this kind of a record, they don't have an @ sign for this, so it's Wilson DNS, and then you just have to understand that that would actually be an @ sign, asu.edu. But pretty good chance that in most cases, that's not really a live person on the other end of that email address. It could just go into a black hole or something like that. So in any case, let's go ahead and take a look here at another thing, and that would be whether or not we can get zone transfers out of this domain. Now, I'm pretty sure that we're not going to be able to, but let's just go ahead and give it a shot. First thing I'd have to do is I'd have to set the server. So I have to identify which server I want to pull the zone records from. So I'll do server. What was the, yeah, there it is, asudns4.asu.edu. And then I'll press enter. And then next thing I'll do is an ls-d. This is going to pull our records from the domain. And it's going to do a zone transfer if it allows zone transfers. Again, I'm pretty sure asu.edu will not, but let's give it a shot. Okay, sure. It was refused. Query was refused. So could be a number of different things going on there. Remember earlier we had a diagram of a network where we had a DMZ and a firewall on both sides. Well, the firewall that faces the public internet probably blocks TCP port 53. This means that it wouldn't even be possible to pull a zone transfer through that port. Because again, TCP53 is what's used for zone transfers. UDP53 is what's used for DNS queries. So it probably does allow UDP53, but not TCP53. All right, here I'm going to another prompt, and I've again started NSLOOKUP, and this time I'm going to try to do a zone transfer from another DNS server. This one's internal, but let's see if it's going to allow zone transfers. So NSLOOKUP has been done. I'm going to do set type equals SOA, so I can figure out what the what server is the primary name server, and then I'm just going to type in mail, that's the name of the local domain here, mail.local. Press enter. Okay, my primary name server is w2ks.mail.local. So I'm going to type in server here, because this is the server I want to retrieve the records from. Server is w2ks.mail.local, and it'll resolve the address for me, and it's done that as you can see there. Then I'm going to do again an ls-d to retrieve the records, and then the name of the domain, which is mail.local. and press, ooh, and we got quite a lot of information there. In fact, that kind of went by pretty quickly, and I might want to store some of that information somewhere else to look at later. So let's just do this a little bit differently. I'm going to pipe that out to zone, okay, zone.txt. So I'll do the same thing, and then this time I'm going to go into my file system, and using Notepad or something, it's probably put it in the root here, so we'll go to zone.txt, and we see that we have all of this information that it's been able to dump out. Well, what kind of information can we get out of this? Well, there's our startup authority. All of this has to do with the refresh interval and the time to live. There's our time to live. So that's just the same kind of stuff we saw a little bit earlier. But some new information that we've got here. First of all, one thing that sticks out to me is SRV records. Well, that's a dead giveaway to, in most cases, a Microsoft Active Directory infrastructure. I've got SRV. I've got port 88 open for Kerberos. That's another indication that I've got something going on there relating to Microsoft. It's not that Microsoft owns Kerberos or they're the only ones, but it's a pretty good chance in this case. Okay, so we see some information like that. We also see an MX record. That's a mail server. This is something I might want to go up against, and we'll take a look at that a little bit later on. Might try to see if I can exploit that mail server. We have, I thought I saw something else here, just, a SQL server. At least that's the name of the host. That might be just a distractor. It might not be a SQL server at all. It might be some kind of a honeypot. You know, if you're not familiar with a honeypot, this is a server that is designed to look like an attractive target, but with a lot of misleading information in it, so hackers just waste their time with it. It allows us to study what the hacker is doing as well, and study their methods. So it could be a honeypot, could be a real target. Here's the www server for it. It's got a CNAME record that points back to Web 4. So this is actually, Web 4 is going to be 10.10.10.54. Again, now we know our web server to attack if we want to do that. So anyway, pretty good information that you can get out of a zone transfer. Lots of juicy tidbits. A lot of corporations will usually name their servers according to what they actually do. You know, file server 1, something like that. And that's because it has to be usable and somewhat intuitive, but it also makes it intuitive for the hacker so that we can easily guess what kind of purposes each one of those servers has, and now we also know what each one of their IP addresses is. Now, if you prefer to use Linux tools, then of course you can go to a command prompt and you can just use your other commands. You know, you want to do a dig against a specific domain, mail.local, what the name servers are, tells me what the name server is. The name server is identified as w2ks.mail.local. You know, you could do a similar thing to find out the MX records. Okay, there's my MX record, again, the same server in this case, but it would identify any of the MX records I had. Similar thing I could do with the host command. I could just do a host -t to transfer the name server records to me here, mail.local. And that shows me the name of the server there. Again, same server, just a little bit different output, a different look. So, you know, you can use the Linux tools as well as GUI tools like samspade or NSLOOKUP from within Windows to get all this information. Well, now just for fun, let's go ahead and run an exploit against that mail server. It's not really an exploit, but just a hack. We'll go ahead and run something against it to see how vulnerable it is. And we're going up against the mail server here. So remember what we do in order to confirm that services are running and to be able to see how far we can go? We use telnet. So we'll go ahead and go up here and telnet. And I'm going to go to the IP address of that mail server, which is .42 on port 25, which is SMTP's port. That's what I want to do. It's to see if I can get SMTP action out of it. Now, I might not always even get the answers I'm looking for. I just want to see if it's going to send anything back to me. I'm going to type help. Remember, that's what we commonly do to see what kind of commands it'll accept. I see hello, extended hello, you know, start TTL. I see several different things here. Let's just do a hello localhost, and this is going to see whether or not it's going to be able to send a message back to me. And it says nothing. So apparently we didn't. But strangely enough, I type it in again and it gives me an answer. Well, that's just the way things go sometimes. So sometimes you have to try this thing 2 or 3 times. There's no real explanation for it. But anyway, now I got an answer back, so I know that there is some communication that I can use with that item. Now, another thing I could do here is if I want to see if it's a Linux box or some kind of a Unix mail server, I might do verify root. To see if I can get anything out of that. And again, I might try this a couple of times. VRFY, I guess it helps if you type it correctly. Can't verify the user, but it will take a message at that mail address. There's probably some kind of a lost mail kind of a thing, or a forwarder where it will dump that mail or send it into a black hole or something like that. Another thing that I could do would be to go and let's try a verify administrator. and keep on going. So you can just see if you can find any live addresses that you can take advantage of. Now let's go ahead and do another thing here, however. I'm going to go this time to an extended hello localhost. And again, see if I get anything. Oh, now this is interesting. Now I'm just getting more information back. The key here is, what does all of this stuff mean? I don't know, and I don't care. Again, that simply means that it's willing to communicate with me on an extended level here. So once I see that it's dumping information back to me, I'm just going to keep typing. I'll just go this time. How about trying to start sending some mail? So mail, I know that it'll take mail because earlier, remember we saw that it'll take mail commands. So I'll just type mail, and then I'll enter in from, how about James at wherever.com. Now this is what a spammer would do. This doesn't have to be a legitimate domain. This could be the name of somebody's bank, for example. And I'm not going to name any, but this could be the name of a bank, and I could make it look as if I'm customer service from your bank. We noticed that there were some overdrafts from your account. Please click the link below. And then when they click the link, it loads a Trojan horse on their system or something like that. So I press enter. It says sender okay. Oh, that sounds pretty good. Receipt to, and then, James at nowhere.com. Okay, and then what I want to do here is just really give it some data once I've started all of that. And then all I have to really do is to say, hi, your account has been compromised. Okay. Whatever, bad punctuation, I know. But anyway, I'll enter that in. So then I'll just do an enter, enter, and then it says it's queued the mail for delivery. What I just did is I just sent mail through that server with the administrators there completely unaware of what I did. This is something that we call an open relay. If you can find an open relay on the internet, the spammers will just love that because they can send mail all night, millions of messages to wherever they want them to go by using this kind of a method. And in reality, this is just what they would do to try to see if it's available for an open relay, and then they'll use other utilities and things to be able to mass mail through that open relay. In this nugget, we discussed DNS, or the Domain Name System. We took a quick overview of DNS, saw how that queries could be referred from one DNS server to the next and then returned to the client. And that was also important in understanding how that we can then do cache poisoning and to put false records into a cache so that we can direct clients to whichever server we want them to go instead of where they think they want to go. We also took a look at separating the namespace. This is pretty important in terms of security purposes. Microsoft does not like overlapping namespace where you have the same name internally for Active Directory as you do externally for your public web servers and things like that. You can use bind split horizon, or you can just name them separately, or some other solutions, which I briefly address here. Then we took a look at querying DNS as well. That's going to be important to do in a critical hacker tool. You can use command line tools like NSLOOKUP in Linux or in Windows, or you can use Sam Spade, or you can use host and dig from within Linux. Then finally, after querying our DNS servers, we found an MX server that we were able to send mail through using the SMTP's open relay. I hope this has been informative for you, and I'd like to thank you for viewing. Now, has anybody seen the remote control?